Welcome to the distance learning program on cloud computing by Innovus. In this chapter, we'll be covering the topics of Amazon Web Services. What are the different services offered by Amazon Web Services over the cloud for the end user? As we know, Amazon started AWS for running their own business, Amazon.com, and later they've started the AWS Web Services, and they've given that to the public for running the web or mobile application onto the cloud infrastructure. And as we discussed before, Amazon Web Services uses Zen hypervisor for the virtualization technique, and AWS also offers the services over the cloud under 5 different categories. Let's take a look at what are the 5 different categories. The first category is compute and networking, where we have the networking products as well as virtual servers, and we have storage and content delivery, where AWS offers services for storing database and also for content delivery network, where the end user can use that technology for increased performance of the server or the web application. And products offered under database, where we have relational database systems from AWS. It also offers deployment and management services or products, where the end user can go ahead and build his or her application and also automatic deployment. All these services are offered under deployment and management category. AWS also offers services for running different applications like mail and notification services, etc. Now, let's go ahead and check what are the different services offered under compute and networking category. The first one is EC2. So, as the name indicates, it's also known as Elastic Compute Cloud, where we have virtual servers. It also offers another service called Elastic MapReduce, and we have another networking component under this category, which is Route 53, and also the virtual private cloud VPC comes under the compute and networking category from AWS. Let's look something deep into EC2. Okay. As the name indicates, it's Elastic Compute Cloud. It gives the feature of elasticity under this category. And what is EC2? EC2s are servers running on the virtual network or virtual cloud. The servers are, as we know, the servers are on top of a Zen hypervisor. AWS uses Zen for running their infrastructure. And the EC2, it has the computing power, where the end user gets the RAM, memory, all these features for running or a process from the EC2. Let's check what are the different attributes under the EC2. Okay, let's check what are the different types of EC2. In AWS, EC2 are called as EC2 instances, and there are 2 types of instances. And first one is EBS based instance, and second one is instance store instance. And what are zones? As we know, the cloud infrastructure is spread across the world. They have different zones for running the infrastructure. And the different zones in the case of AWS are, they have zones in US. In US, they have got nearly 4 zones. US is 1, 2, and US is 4. And also they've got another zone in South America, and another zone is from Europe, and they've got zone for Asia Pacific. And let's see what is elastic block storage. As we know, EC2 instance is a virtual server running on the cloud. So in order to keep the data or huge amount of data in the EC2 server, we use the elastic block storage. These elastic block storages are user defined. The end user can go ahead and define what should be the size of elastic block storage which we need to attach to our EC2 server. And these storage instances it can be attached to a Windows instance as well as to a Linux instance. And now let's check what is security groups. Security groups are considered to be a secondary firewall for your EC2 instance. It is where we configure the server for handling the traffic on different ports. In security groups, we can go ahead and define on these ports. For example, in the case of HTTP, we go ahead and open the port 80 across all IPs 0.0.0 to be ready to handle the traffic. And also for SSH, we go ahead and open the port 22. So based on the rules that we configure on the security group, the EC2 instance will behave. And let's check what is a load balancer. AWS provides a load balancer and it works along with the EC2 instance. In normal case, we have a web server which is capable enough to handle a number of incoming requests, say like 500, and also a simultaneous request of 300 requests. And in the case of where we are expected to have more than 1000 incoming requests simultaneously, we need to set up another server in a traditional case. And in case of AWS EC2, we can go ahead and create a load balancer where the load balancer will check the health of our EC2 instance, and if the instance is capable enough to handle the incoming requests, say like a 700 request, if the load balancer detects that EC2 instance is not capable enough to handle any more requests, it transfers that request to another EC2 instance which we need to configure manually. We go ahead and mention 2 or 3 EC2 instances and we attach that instance to the load balancer, and the load balancer automatically senses the health of all these 3 EC2 instances. So based on the health, load balancer transfer the incoming request to each and every EC2 servers. And what is autoscaling? Autoscaling is something like making our infrastructure ready to meet any kind of peaks in the incoming traffic. In normal case, a web server would be ready to handle a 300 incoming requests, and there are some scenarios where the business should be ready to meet any type of incoming request, and creating another server or number of servers to be ready to handle the incoming request is not a good idea, since we have to waste a lot number of resources available. And if it is in the cloud or in the traditional way, if we are using a server without any reason, it is wastage of resources. So in the case of cloud and in the case of autoscaling, based on the incoming request or based on the peak request, the Amazon EC2 will automatically become elastic, or it will make itself ready to meet the incoming request. It's a process where the end user go ahead and create an EC2 instance, and by setting up the bundling and autoscaling based on the incoming request, the EC2 instance will be, or another EC2 instances will be automatically fired up to meet the incoming request. And when the incoming request is normal, or if it is off peak, it will automatically shut down the instances which they have automatically created. We'll be looking at all these points deeply when we are creating the EC2 instances. Let's go ahead and check how we can create or how we can launch an EC2 instance in the AWS Management Console. Here I open up the browser and I go to the AWS Management Console page. You can also reach that at aws.amazon.com and the Management Console link. And here I'm going to log in as an administrator, where we can go ahead and create an EC2 instance. Let me log in. So what we are going to do is, like, we are going to create an EC2 instance. And as we see, all those 5 different categories are mentioned over here. So we go to the tab which is mentioned as Amazon EC2. From where we can launch an EC2 instance. It may take a while to load the page, and we got the page. So we can see a link which is called a launch instance. I go ahead and click on the launch instance button. And there are 2 different ways where we can go ahead and create, or where we can go ahead and choose to launch the instance. We choose the classic visit to launch the instance. We click on continue. Here, as we said before, in Amazon, the instances, or the EC2 instances, are based on the 2 different types. It could be EBS store, it could be instance store. And also it offers a wide variety of operating systems to choose from. It offers operating systems in Red Hat, in SUSE Linux, Ubuntu, and also Windows. All major flavors of CentOS or Debian flavors are being offered under EC2 instances. And all these are mentioned as AMI, which is also known as Amazon Mission Images. So there are 3 different ways from which we can go ahead and select an OS. So where, as you see, we can go ahead and select a 64-bit or a 32-bit if we are planning to choose an Amazon Linux AMI, and the same for Red Hat Linux as well as for SUSE Linux. So I'm going to select my OS from Community AMI. Now let's go ahead and launch an EC2 instance based on Ubuntu OS. Alright, now I've typed the keyword Ubuntu, and where AWS has given a list of Amazon Mission Images, which is AMI, based on the OS Ubuntu. And we can also filter our search, like, I've selected all images with the keyword Ubuntu. We can go ahead and also give EBS based. It shows only the images which are EBS type. And also we can go ahead and filter between 64-bit and 32-bit. And also we have got another category where the images would be public images and private images. The private images are something like where we can go ahead and create our own images and we can keep it in our own profile. So if we have something with Ubuntu as a private image, that would be listed over here. Since we don't have anything, it seems to be empty. And let's go back to EBS images. Let's go ahead and select a 64-bit based Ubuntu to launch our EBS instance. I select the 64-bit Ubuntu AMI from the AWS Management Console here. We click select, and now here we got an option to select how much number of instances that we want to use or we want to launch in a single click. If we want to launch only one instance, you can go ahead and click 1 there. And if you plan to launch instances of a same AMI, and if you want to give, or if we want to launch 10 instances at the same time, we can go ahead and give 10. By this time we are going to keep it in 1. And what are the different instance types? We have number of different types under AWS. We have got T1 micro, where we get a single core with a 613 MB of RAM. And when it comes to small, we get 1 core and 1 CPU and 1.7 GB of RAM, which is known as M1 small instance. It has also got high CPU high CPU instance, where we get 5 elastic compute units, that is what is ECU, and that too with 2 cores and 1.7 GB of RAM. And it has got different instances type like medium, large, extra large, and these are like where the end user gets the benefit of number of CPU core processing units. We get in extra large, we get 8 elastic compute units, that with 4 cores and 15 GB RAM. And in the large one, we get 4 compute units, 2 cores and 7.5 GB of RAM. And when it comes to high memory, extra large and high memory quadruple, in case we are running a CRM or a web application which should be capable enough to handle millions of requests at a time or simultaneously, we must need to select any one of the high memory or high CPU instances. So in this type, I'm going to select a micro instance over here. And now we got, as we discussed before, it provides EC2 under different zones. As we discussed before, it has got zones under US, UK, and Asia Pacific. Now here I have selected US region. As we can see here, under the US region, it has got 4 different zones: US East 1, A, B, C, and D. I'm going to select D over here, and we click continue. Also, there is one more other type of instance where now we are launching the instance. We can also request for a spot instance. What comes to the spot instance? As we know, in AWS, we got a number of instances in the cloud infrastructure. So when we launch an instance which is on-demand instance, and we go ahead and select our OS, AMI, and we launch the instance. And in the case of spot instance, we give the request to AWS, I need an instance from AWS, and AWS decides from which zone or from which infrastructure group we can, or the AMI or the instance could be allocated to us. So in that, what is the benefit is that, imagine an infrastructure with 100 EC2 instances, and where the 98 EC2 instances are being used by number of customers and 2 instances are not being used. So in the case of spot instances, the Amazon will give you any one of those 2 instances, and if you require 2, it will allocate those 2 instances into our profile. And the benefit is that under the spot request instances, the expenses that we pay for running the instance would be 32 or 40 to 60% much lesser than the on-demand instance. And now we are going to move up with on-demand instance here, and we click continue. Here we can see that we have selected 1 instance, and that too in the availability zone of US East 1D. Okay. Amazon, it also gives where the end user can go ahead and choose a specific kernel or RAM disk to use with the instance that we have selected. So if you have to select any particular kernel ID, this comes if we have already using a particular AMI for particular application which has particular packages installed. We can go ahead and select any one of these kernel ID which we have already used before. And in this case, we haven't used any other AMIs, so we are making it as default, and also the RAM disk ID we are keeping it as default. And it also shows termination protection. As we know, we can go ahead and launch an EC2 instance, and at any point of time, if we think that we don't need the instance anymore, we can go ahead and stop it. So at that point of time, when we click the stop, it has showed 2 different ways. Like the shutdown behavior, we can set it as stop or we can terminate. That means if we stop the instance, it will be automatically terminated, or if we stop it, it will be in the stop condition where the end user can go ahead and start it again in the future. And what is termination protection here? As we know, we can go ahead and start the instance and we can stop the instance. And also, if we don't need that instance anymore, we can go ahead and click on terminate to terminate our instance. So if we click here, termination protection, even if we click the terminate button, the instance won't be terminated from our profile. So I'm going to keep it as it is, and we're going to click continue. Here, the user gets a feature to add a tag to his or her instance. Why we use this is to simplify the administration of the EC2 infrastructure. The identification of the EC2 instances running under our profile would be much easier if we use the name tags here. You can go ahead and type and give a value for the meta tag that we are going to add to our EC2 instance. here comes another part. We access our instance through a key pair. That's another security provided by EC2 instance, where the end user is connecting to the EC2 instance using a key pair, which is .pem key. So by this time, since we are going to launch a new instance, I'm going to create a new key pair for accessing this instance. And we can give a name for this. And after we give the name, we can go ahead and create and download the key pair. One important thing under this category is that if we lose this key, we won't be able to access that instance anymore. So we need to be careful with this key. We need to always have a copy of this key to access our EC2 instance. We click and to create and download. I've downloaded that EC2 instance, that key to access the EC2 instance. Okay. After that, we go to the next stage where we can go ahead and select a security group. As we discussed before, what we have, we can go ahead and say different port numbers through which the communication has to be given or transferred to our EC2 instance. I've already have 3 different EC2 security groups here. I'm not going to use any one of them. Let's go ahead and create a new security group for our new instance. I will give the name to identify that security group and also a description. Okay, what we have here, see, we can create a new rule here. I'm going to write a rule to open port 80, which is 80 HTTP. And if I give a particular IP, if we have to isolate our EC2 instance to be accessible only from a particular static IP, we can give the public static IP and the subnet here, and we can add the rule. So in this case, I'm going to give it as 0.0.0/0, where we can go ahead and have the traffic on port 80 from any IP from anywhere in the world. We go ahead and add rule. We can see that over here. And also, to access the server, we also need the SSH port to be opened. And I'm not going to mention my static IP over here. I'm going to mention it as 0. That means we can have, or we can SSH to the server from any part of the world, from any IP, I mean to say. I add the rule and we click continue. Now, finally, here we get another different page before we launch the instance, which says what is the number of instance and what is the type and what is instance class, if it is an on-demand or if it is spot instance. All those things will be mentioned over here, and the key pair name and the security group that we use here. So we click launch and we click the close button over here, and now we have launched the instance. So in order to see this instance, we need to click on the instances tab under the EC2 dashboard. I click on the instances. Here we can see that our instance is getting ready. The state is pending. That means it is initializing, and that would be ready in a moment. Now we can see that the instance is in the running state and status check is initializing. Now here we can go ahead and mention a name to identify our instance, and I'm going to make it as Unibus, and I save it. And we need to wait until the initialization gets completed. Now we click on refresh and we can see that status check has been completed and our instance is running. Click on the radio button here and we can see what are the different features or another monitoring features of our EC2 instance. So one important thing under this category is that the public DNS. Public DNS is something which we use to access our EC2 instance. So now we have launched the instance and our instance is up and running right now. So, and as we discussed before, we can go ahead and add a volume to our EC2 instance. I'm going to create a new volume. So under the EC2 dashboard, we click on the volumes and we come to this page and I click on create volume. This is what is the EBS volumes that we attach to our EC2 instance. So I'm going to mention 10 GB of size for my EBS volume, and I'm going to select the availability zone in which we have launched the EC2 instance, which is US East 1D. And I'm not going to select any snapshot. If we already have different snapshots in our profile, that would be listed over here. I'm not going to select any snapshot here. I'm going to create this EBS volume of 10 GB size, and as we see, it's available. So now it's not attached to any of our EC2 instances. We go ahead and right click on top of that volume which we have created right now, and I'm going to attach the volume to the EC2 instance that we have launched right now, which is InnoBus, and it shows the mount point where the EC2 instance will be mounted, and I click yes, attach. Then the volume would get attached to the EC2 instance that we have launched right now. We can see the description over here that it's attaching, so we need to wait for a while when it completes the attaching process. Now it says attached. Now, as we discussed before, EC2 instance also have elastic IPs, where we can go ahead and add elastic IPs to our EC2 instance. I'm going to create elastic allocate new IP address, and now here we get two different types or two different parts to select. We can select an elastic IP for an EC2 instance or for virtual private cloud. I'm going to select EC2 here, and I'm going to click on yes, allocate. So we get the new elastic IP here, which is 23.186.138. I'm going to right click on that, and here I can go ahead and associate my elastic IP to an EC2 instance. Now I click on associate, and we get select the EC2 instance tab. I select InnoBus here, and now I click on associate, where the IP will get associated to the EC2 instance that we have launched right now. I click on the instances back. Now we can see in the InnoBus the IP is attached. So now let's go ahead and connect, or let's go ahead and try to SSH to this EC2 instance. Okay, how we are going to access our EC2 instance? Okay, we right click on the EC2 instance and we click on this connect, and we select connect with a standalone SSH client. Okay, here it shows how we can connect to our EC2 instance. So this is it. If we are using a normal Linux machine, we can go ahead and connect with the key which we have downloaded from the AWS Management Console. And before we do that, we need to make sure that we give a 600 or 400 permission to our PEM key. And by this time we are using a Windows machine, so we are going to use PuTTY and PuTTYGen to connect to our EC2 instance. Okay, it shows the identifier key, which is InnoBus EC2.pem, and the IP address, and we log in as Ubuntu when we use this key. We can go ahead and copy and keep it aside. I'm going to close this. So now I'm going to select PuTTYGen to connect to our EC2 instance, which is another task, because with PuTTY we can go ahead and connect to our EC2 server if we have a username and password, and in this case we have a PEM key. So I'll show you how to connect to the EC2 instance from a Windows machine using the PEM key. Now I'm going to use PuTTYGen. So what we are going to do with this PuTTYGen is that we go ahead and convert our .pem key into a .ppk. Then only we will be able to connect to our EC2 instance from a Windows machine. Okay, I'm going to load our key which we have just downloaded. So we go to downloads and I'll select we have to select all files here, then only to list the .pem key. I got the innobus.pem file here, and I click select and I click OK. Now it shows the key which we have imported to the PuTTY, and we click load, and it's already loaded, and we click save private key, and it will ask you whether we want to protect that key with a passphrase or not. And now I'm going to save the .ppk file here. Okay. And we save it over here. Save. Now we have converted the .pem key with the PuTTY. Now we got a .ppk key with which we can easily connect to our EC2 instance using normal PuTTY. So I'm going to launch PuTTY over here. Click run. Here we need to enter the host IP address, where I'll paste the IP address of our EC2 instance, which is our elastic IP, and I click load. And now before I click load, what we do is, like, on the left hand side we can see SSH here. We click on SSH and we can see authentication types. Okay, here we go ahead and browse our .ppk key to access our instance. So I got the innobus ec2.ppk file here. I open it and I attach that to our EC2 instance. So now we go ahead and click on terminal again, and we click open. So the IP is being listed. Now it's asking for you to save the host key. We click yes. Now it's asking for you to log in as. When we clicked on the connect button, we saw that we need to log in as Ubuntu user. I'm going to click on type as Ubuntu, and so this time it won't ask for the password because we have logged into the server using the key file, the .pem key in case of Ubuntu. And in Windows, what we see here is, like, we got a .ppk file to log into the server. So we logged in as use, and to become logged in as Ubuntu, and to become the root user, we go ahead and type sudo -s and become the root user. And we are in the home folder right now. Now let's go ahead and check where we can go ahead and see our server through a browser page. So before that, we need to have a web server installed on our EC2 instance. So let's go ahead and install a normal HTTP, otherwise an Apache package, onto our server. We go ahead and install Apache 2 here. Since we are the root user, we don't need to type sudo anymore. We can go ahead and type apt-get install Apache 2. Before we install the package, it would be nice if we go ahead and perform a repository update over here. We can go ahead and type apt-get update. That is a good practice or best practice in case of EC2 instances. It's better to update our EC2 instance before we install any new packages. And it shows it's updated now. Let's go ahead and install apt-get install Apache 2. We click yes, and the packages will be installed right away. Let's wait until that. Okay, now it says it has been installed. So let's go ahead and check whether port 80 is being or is getting listened on our server or not. It seems like the port 80 is up, so let's go ahead and check whether we can access our EC2 instance. To identify that our instance is running, let's go ahead and edit the index.html page, and so that we can confirm it's our Inobus EC2 instance. So it says it works, so let's go ahead and add Inobus here. Okay, I'm just editing the index.html page just to identify that our web server is working and the communication is possible through port 80, and port 22 is already working. That's the reason we are connected to our EC2 instance through the SSH connection. So I have saved that, and let's go ahead and perform Apache reload so that the things will get right in place. Okay, the Apache has been reloaded. Now let's go ahead and take the browser and let's check whether we can see the same through browser or not. Alright, we're back to the browser page, and I open a new tab and I enter the IP address, and we can copy the IP address from the AWS Management Console, and let's confirm that we have copied the right IP address, and we paste it over here in the new tab. Okay, we got our IP over there, and we go ahead and click load the page, and here we go, we get it works in Inobus. So right now we have configured and we have launched the EC2 instance, and we have installed the web server, and we have accessed that page through the IP address. So if you have to run a web application, all that we need to do is mention the IP address with your domain registrar for the domain which we are using in the EC2 instance, and configure the code and the DB on the EC2 instance, and using the domain name we will be able to access our EC2 instance through port 80 on HTTPD. Now we can also see that the EBS volume which we have attached to the instance are also in the list. Let's go ahead and check how exactly it's listed here. And to check that, we need to go back to the volumes, and we select our 10 GB volume which we have just created for attaching this to our EC2 instance, and it shows like in use, and it's been attached to the Inobus ID. And if we didn't give the name, we can see that in AWS there is an instance ID which is unique to each and every instance. So this ID IB7A8F1D1, which is the instance ID of our Inobus instance. So we can go ahead and click on instance, and we can check that instance ID. Yeah, it's correct, IB781F1D1. So we have attached the EBS instance, we have attached Elastic IP to our instance, we have installed the web server, and we have verified the same through a browser. This is how we install and launch an EC2 instance in the AWS Management Console. And we can also make changes to our Elastic IP. As we said, it gives flexibility and elasticity in all resources that we use. We can go ahead and disassociate if we think that we don't need this IP anymore. We can go ahead and disassociate this IP from the EC2 instance, and that won't be attached, and we can, so now it says associate, that means it's not associated with any EC2 instances. And we can go ahead and also press release if we want to release that EC2 Elastic IP from our profile, so that won't be listed anymore. So now we can also check another case, like we can go back to instances, so just perform a refresh over here, and even after detaching the IP, it might list that it's associated. It may take a while to list that it's not associated to that IP. It's the GUI refresh, which takes a little time over here. So we perform refresh 2 or 3 times to get it done. Let's wait until it gets completely removed from the profile. So it may take a while to get that IP removed from our EC2 instance. So meanwhile, let's go ahead and check how can we edit and add firewall to our EC2 instances. So we go to security groups under the EC2 dashboard, and here we can see the different security groups we have mentioned. So we have got InnoBus here, which we have attached to our InnoBus instance. So we click on the inbound. Here we can see that we can also add different rules to our EC2 firewall. So we can select any of these protocols, so we don't need to enter the port address anymore. So if we are using any custom port, imagine that we have changed our SSH port to something else other than 22. We are running it on 5678. If we are doing something like that, after you make changes on SSH config file, come to the firewall, EC2 security group, and enter the port range. If you're using it on a dummy port or something other than the default port, we go ahead and enter the port number over here, 6895, and if we want to limit access to the server from a particular group of IP, we go ahead and enter that static IP. If it is not there, we keep it as 0.0.0 and we click on add role. After we click on add role, we have got another button which is apply role changes. If we click on apply role changes, then only the firewall will get reflected for these changes. And if you want to delete any of this rule, you can go ahead and click on delete that particular rule and click on apply rules changes to get this in effect. That's how we add rules to the firewall in this settings. We can also create snapshots of our EC2 instances. Let's see how we can create a snapshot of our EC2 instance. We click on snapshot under the EC2 dashboard, and it seems like it's taking a long to load the page, so let's wait until it completes that loading phase. Alright, now the loading is completed and we click on create snapshot. Now it shows which volume that we need to create a snapshot from. So before we create the snapshot, we need to know from which volume. That means we need to know the volume ID of our instance. So we click on cancel and we go back to our instances. So we can see InnoBus over here. So and the instance ID is IB7 starting with. So we go back to volumes. Under the volumes, we click on the volume which is 15 GB and 10 GB, and we see which is the volume that is attached to our EC2 instance. So this is another one. So we click on another instance. The volume ID which starts with 850 is being the one which is our EC2 instance, and we see that it's 850. So we go back to snapshot, we click on create snapshot and we select the volume ID which is 850 starting with, and we give a name which is snapshot InnoBus. We give a description as well. It could be anything that we need to identify this snapshot again in future, and we click on create. So here it is creating the snapshot of our EC2 instance. So what's the benefit of creating a snapshot? We can go ahead and create, or we can go ahead and take a snapshot of our EC2 instance and we can keep that in our profile, and this helps us to be ready to face any kind of disaster which happens to our EC2 instance or which happens to our data. We can keep our server as a snapshot aside in our profile, and in case of a disaster recovery, or in case of any other service down, or in case of expanding, or in case of changes, we can go ahead and use this snapshot from where we can go ahead and take the data of our EC2 instance. A snapshot is just a mirror image of our EC2 instance. Without losing any data, AWS will keep the snapshot, and that will be a data copy of our EC2 instance. So the data backup and redundancy will be taken care of by using the snapshot in case of normal EC2 operation. Since AWS also provides another data storage options like S3 and RDS, so this is an option where we can create a mirror image of our EC2 instance, and now it says the status is completed. So we can go ahead and attach this snapshot to any of our EC2 instance, from which we can go ahead and take the backup of our EC2 instance. How we do that is like, we create a volume out of this snapshot, and we right click on that and click on create a volume. So what should be the volume size? I keep 20 GB here, and I select US East 1D, and the snapshot volume should be the one which we have right now. Since we got only one snapshot, that's the one listed over here, and we click yes. And other these snapshots are of Amazon itself, from which we can select if we want. So we select the snapshot of our instance and we create the volume. Now, to check if the volume is created or not, we need to go back to the volumes tab under the EC2 dashboard. So we have 5 volumes here, which is now available, the 20 GB. Now we can go ahead and attach this volume to our EC2 instance. We can go ahead and select Inubus over here, and it would be mounted on /dev/sdg. So when this gets mounted to our EC2 instance, we can go ahead and access data from our EC2 instance. And since the 20 GB is being attached as a volume, we can go ahead and move, or we can go ahead and check our server with this mounted volume, and we can take the data. That's how we perform a normal disaster recovery from EC2 without using any other AWS services. Now let's go back to our Inubus instance where we have removed our Elastic IP. So now, without accessing an EC2 instance, this is how we access. We got to see something called public DNS, which is unique for each and every EC2 instance. So we go ahead and copy this public DNS from the AWS Management Console, and we open a new tab and we paste that public DNS IP into the browser. And here also we can see that it works. Inubus, our web server, is serving the content. So even without an IP, we can go ahead and use an EC2 instance, and we can use this public DNS name to access our EC2 instance. And if we check the IP over here, we press refresh, and since the IP is not attached to our EC2 instance, we won't get the page. It says loading, and soon it will say the content, or we might get a 404 error in this since it is not attached to it. It says site was not found. So that's all about EC2 instance in Amazon. So this is how we work with EC2 instances, and this is how we create EC2 instance and configure an EC2 instance. And we have checked volumes, attaching volumes to the EC2 instance, creating snapshots, and creating volumes out of snapshot and attaching that volume to EC2 instance. And also we have checked Elastic IP and security groups under the EC2 instance category. Now let's go ahead and check what are the advantages of using EC2 instances. Let's see what are the advantages of using Elastic Compute Cloud or EC2. Okay, the first advantage is that it is elastic. As we've seen before, we can go ahead and move the Elastic IP from our server to another server. We can attach and detach volumes, and also we can increase the size of volumes. So in all cases, it gives the elasticity feature on all the resources it provides. We can also call it elastic because we can move, or we can attach the resources to it in just a simple click. And another advantage is that it gives complete control through the root user than compared to shared hosting or traditional hosting techniques. In AWS, as we see what we have done, we have logged in as Ubuntu user, and we have changed ourselves to a root user, which is super user, by typing sudo -s. So the complete control to the root is provided by using EC2 instance, and it is flexible. It is flexible in the sense we have launched the micro instance right now. In case in the future, if we think that you need to make this a small instance or a large instance, just shut down the instance and you can go ahead and start the instance. And we can change the instance type. We can make it as large or we can make it as small. that flexibility is being given under EC2 instances, and it is reliable since we are the uptime of EC2 zones, let it be US or Europe or Asia Pacific, the uptime guaranteed on these zones are pretty much high than any other cloud service provider. And another point is secure. How it is secure in the sense, as we see, we got access through key, so without key it won't be accessible. If we want to make it accessible without key, all that we need to do is like making the server to be SSH with password authentication. Yes, we can go ahead and change the SSH configuration with password authentication. Yes, by that we don't need to use the key, and we can make it password protected. And if you want to make it more secure, don't change it, let it be more secure with using access only through the key. And it is inexpensive. EC2 works in such a way where the end user is getting paid only for the hours which we use that resources, and whenever we use the resources or whenever the instance is running, it is counted. So we are paying only for the hour that we're using. If we think that we don't need to run the instance for next 3 days, we can go ahead and stop the instance, and after the 3 days we can go ahead and start the instance. So when we stop the instance for nearly 3 days, we don't need to pay for that 3 days, which is another advantage of AWS EC2 services. Now let's go ahead and check what are the other services offered under the compute and network category of EC2 instances, which is Elastic MapReduce. Now let's see what is Elastic MapReduce in Amazon Cloud Services. In a single word, Elastic MapReduce is a managed Hadoop network. As we know, nowadays we are using the Hadoop on most of all services where we have millions of end users being served from a particular web server, and so that's being the Elastic MapReduce is a Hadoop ready framework, in fact. And what is Elastic MapReduce? It's a web scale infrastructure of Amazon EC2 and S3. The Elastic MapReduce is being created with the help of the Amazon services like EC2 and S3. In other words, we can also say that Elastic MapReduce is a service which runs the Hadoop network on Amazon EC2 and S3. Before we proceed furthermore with Elastic MapReduce, let's go ahead and check what exactly Hadoop and how exactly it works. As we say, the Elastic MapReduce is a Hadoop ready infrastructure. Let's see what exactly Hadoop does. Hadoop is a software library, or we can call it as a framework that allows for distributed processing of large datasets across clusters of computers using a simple programming model. That's what is Hadoop, in fact. And Hadoop is designed to scale up from single servers to thousands and thousands of machines based on the requirement of the incoming traffic, and that too each from the EC2 point of view and from S3 point of view. It gives computation being served from EC2, and S3 provides the storage. So it basically works on the demand of the end user or the traffic on a particular port. Another feature of Hadoop is that Hadoop is designed to detect and handle the failure at an application layer itself. Instead of getting failed at a network layer, it works in the application layer. So it detects the failures in the application layer itself. So delivering a high availability service on top of a cluster of computers. That's how Hadoop works. And since it detects the failure itself, it automatically works accordingly. If one fails, it automatically fires up another server or another cluster to handle the incoming infrastructure. That's the basic idea of Hadoop technique or Hadoop technology. So here in Elastic MapReduce, it is basically designed to work as the Hadoop technology works. And let's see what are the different applications which can be served through Elastic MapReduce. The Apache Hive process can be served through application, through elastic MapReduce, and also for streaming, a different kind of streaming, say like YouTube or any other, a single server or a single service, a web service which is used for streaming of a particular audio or a video, or even a particular number of audios or videos to n number of millions of large users, can be made available to the end user using the elastic MapReduce. And also word count. Imagine an inventory system or the CRM system which has n number of users or user data. The word count of application can be implemented using the elastic MapReduce. These are the major applications which we can use with elastic MapReduce. It's all about the logic, how we apply the Hadoop network into our web service or the web application which we need to run, and which needs to be highly available among millions of users. That's the point where we implement elastic MapReduce. So let's see how exactly the elastic MapReduce implements Hadoop. Elastic MapReduce automatically spins up the Hadoop implementation of MapReduce. And how it works, in the sense, it subdivides the data in the job flow into small parts so that they can be processed in a parallel way using number of EC2 instances parallelly, and which is used for processing this data. And finally, the recombining the processed data into a single solution. That is the basic idea of elastic MapReduce. So if you look at the job flow, it stores the input data in S3, and the EC2 is the compute unit which processes the data, and the output is getting back to S3 for storage again. So let's see how the job flow goes. So this is how it works. The job flow, the data comes and it's checked for what is the bootstrap action, where we mentioned this has to be done with this data, and the process steps. Based on this action, the data is being processed, and after the processing, it checks whether it is being configured to wait in case of any other more data, and if there is no any more data, it completes the process. And since the process does not require to wait for another data, since it's completed processing the input file, and it goes to the shutdown state. That means our EC2 compute units are being shut down after processing, and the data is getting stored onto the S3. And if it is designed to work in such a way where it has to wait for another data, in case of we are combining the data, or we are working with two or more or a number of input sequence, it waits for another data, and when it gets the data, it starts processing again, and it completes the output file, and it gives to the S3 as we discussed before. And if the job flow is in a waiting condition, when exactly it comes to the wait condition, that means the processing file has some issues, or in other words, the processing file is not being working properly. In that case, it will automatically terminate the EC2 instances into shutdown, and the job will be terminated, where the job won't be in a completed state. So that means the elastic MapReduce will not complete or will not process the job if the process file or the process stage is not fine. And another option is that where the job flow itself becomes failure, that means the job is not getting completed due to the input file error or due to the processing file error, it will shut down the EC2 instances that we use for processing, and the job will result in a failed state. This is a small idea of how exactly the job flow works in elastic MapReduce. When we do the practical, we will come to know how exactly it works. If we look at this figure, we can understand how exactly the AWS elastic MapReduce works. We can see the master instance. Master instance, what exactly it does is like it takes the data from the input bucket, that means from S3, and it gives this data to the task instance. And what it says, the core instance will be having the processing the power, and what exactly it does is like it detects the task instance. If any one of the task instances are down, it will replace it with another one. And since the input data and processing the file, that means the file which says what has to be done with the data, that's the process file, and the input data are being given to this part from the master instance. And after the process is completed, the data, output data, will be stored on the bucket for storing the output. Now let's see how can we configure and set up Elastic MapReduce in a Amazon Web Service Management Console. Let's go to the Management Console and let's start Elastic MapReduce job, and let's see how exactly it works. When we complete that, we'll come to know how exactly the job flow works, and what is the process file, and what is the input file, and what is the output that we get with the Elastic MapReduce job. So we go back to our AWS Management Console and we click on Elastic MapReduce. So as we discussed before, Elastic MapReduce, it works in combination with EC2 and S3. S3 is for storing the data and EC2 is for processing power. So as the figure indicates, this is how it works. We upload the data to the S3 bucket and we create the job flow, what has to be done with the data, and after the job flow is completed, the output will be pasted back into our S3 bucket, which we refer or which we mention. So let's go ahead and create a new job flow here. So we click on create new job flow. So we can go ahead and give a name for our job flow. I'm going to create it as bus EMR Elastic MapReduce. So we can run our own application or we can run a sample application. Let's go ahead and select a sample application and let's see how exactly the Elastic MapReduce works. So I'm going to select a word count example here. That means a streaming example, in other words. So we click continue. So here, this is what we are talking about. The input location, that means the input file, and output location, where to keep the output after processing the data, and the mapper, which says what is the process which has to be done with the input data, and reducer, let's keep it as reducer, which is as aggregator, which is what exactly it does with the process in Elastic MapReduce. So before we continue with the next, we need to give what is the input location. So let's go ahead and upload a sample input file to our S3 account. So let's go back to let's click cancel over here and let's go to S3. And here what we're going to do is like I'm going to upload a small input file which contains a number of text, a number of words, in other words, and we are going to process it with the process file. So first let's upload the input file to our S3 bucket. So I'm going to create I'm going to use the existing bucket which I've created for this, where I've got EMR demo, Elastic MapReduce demo, and I'm going to create samples, and I've got word count file here, and also this is what I've got a file which is src.txt. We can go ahead and check what exactly that file has. We can go ahead and open it. So let me allow pop-ups. It's done. Let me open it. Okay, this is what my file has. It says 1, 2, A12 and B12, and I'm going to close it. This is what my input file is. And what we're going to do with Elastic MapReduce is that we are going to give a set of input file, as we have seen before, which is used for, well, from which we need to get the data, and as we discussed before, we are going to create a simple job flow with a word splitter example. Word splitter example, what exactly it does is that it counts the word in that text file and gives output what are the different words and what are the different sequences in that. So we come back to here and we type the job flow here, and I'm going to type bus EMR, and I'm going to click continue. So we have seen that I've got the input file over there, so I'm going to give the path over here. Here I'm going to type path name, which is the EMR demo is the bucket, and in that bucket I've got a folder which is samples, and a word count and input. I've got the source file which has the text, and the output I'm going to mention is as EMR out. And what exactly it says, as we can see here, we need to mention the URL of our S3 bucket. We can go ahead and create a new bucket. Let's create a new bucket and let's see how exactly we can create a new bucket for the output. We go to Amazon AWS Management Console. We click on console to move to our AWS Management Console, and we click on S3, and we are going to create a new bucket just for keeping the output of our input data. I'm going to create bucket, so let's say bus out. I'm going to select the region as US standard, and if we want we can set up login here. I'm not create login here. We'll be looking into that under the chapter which comes for S3, and we click on create. So the bucket has been created and it says the bucket is empty. Now we have created a bucket for keeping our output, and I'm going to give the name of that bucket to keep the output. So let's keep the sample data as it is, and we can go ahead and mention it as bus out. Now we have given the input file and we have given the output file. Now we are going to give the mapper, which is the one which performs the operation. We have given the input data, we have mentioned the output location, so we need to say what is the process. So here we're just going to perform a word splitter operation here. So here also we need to mention where exactly the word splitter file, otherwise the file which performs the operation, where it is. We need to mention that location. So let's go back to S3 and let's select the URL of that process file. Now we go back to S3, and I got a word splitter file which I've used before. Let's go ahead and upload a new word splitter file. So we click on upload, so where we click on add files, from which I have to select which file I have to upload to this machine. So let me go ahead and select my files. So I click on cancel, and let me select the word splitter file from my machine. Okay, we upload the new word splitter file, and I've added my files, and I click on start upload, and it's waiting for uploading, and now it's completed since it's a small file. Now this is the file which I have here for processing, so we can go ahead and see that file over here. So we need to give this file as a process file here, so I'm going to mention it as the location would be EMR demo samples, and word count so I have that in EMR samples word count, and I got word splitter.py, so we got mentioned that word splitter.py is nothing but it's a Python file which performs the word splitting with the source file or the text file that we give. So we confirm that again. EMR samples word count and word splitter is a file. EMR sample word count, word splitter is a file, and we keep the reducer as aggregate, and we click on next. Now in this stage we can say how many instances that we need in our Hadoop network. So the master instance, as we have seen on the picture before, the master instance which says the task instance and the core instance what has to be done. So master instance, I'm going to make it as small instance, and we are going to take two instances in the core instance which is in fact performing the operation with the input file that we give, and the task instances we are keeping it as default 0, since the two instances would be more than enough to run our sample application here in the Elastic MapReduce. So we click continue. And what exactly the core instance does is, like, to run the Hadoop task and store the data in the Hadoop distributed file system, we need the core instance group. And the task instance, what exactly it does is, like, it's not used for data persistence, it's used for meet the temporary performance of our compute capacity. So we don't need to select that. Let's keep it as 0 and we click continue. Here we go to advanced options. So while launching EC2 instance, we have seen that we have selected a key pair for accessing our EC2 instance. So here also, if you want to SSH to your Elastic MapReduce instance, we have to select key pair here. I'm not just going to select. If you want, we can go ahead and select our Amazon EC2 key pair. I'm not going to select that since we are going to perform a word count application here. We don't need to SSH to our Elastic MapReduce instance. And since we don't have a VPC running and we are not creating the MapReduce inside a VPC, so we don't need to give the subnet ID as well. Here, if we want to log the operations which is being performed by Elastic MapReduce, we can perform the path of that log file, and the log file we can also keep the same in the S3. S3 is nothing but a storage bucket offered by Amazon Web Services. So in this case, I'm not going to give that log path, and debugging, we don't need the debugging, and let's click on continue. And if you want, we can go ahead and perform bootstrap actions, what exactly has to be done with the job flow, and what are the parameters that the job needs to check before starting the operations in the Hadoop network. So we don't need to, in this case, we don't need any bootstrap actions. So since we are just performing a word clone application with the Elastic MapReduce, that's the reason I'm not selecting this. It's all about the logic that how we apply the bootstrap action in our Elastic MapReduce environment. So let's click continue. So here, before it completes that launching option, it will show you these are the operation that it goes to perform. The input file is the file which we gave, and the output will be stored at its location, and the operation, the mapper, will be the word splitter file. And what are the instance type? That is M1 small for the master instance, and for the core instance as well. Since we have not given any key pair and subnet ID, there's nothing to show over here. And we click on, we have been mentioned any bootstrap actions as well, so we can go ahead and click on create job flow. So now the job, we have created the job flow, so we need to click on close to check what exactly happened with our job flow. We click close. Now we click refresh, and we can see that our job is getting started, so it may take a while to complete the process, so we need to wait for that. Here we can see that the process has completed, so let's check the output. And to check the output, we go back to the S3 bucket where we are supposed to have the output processed output file. So I've clicked on S3, so let's go ahead and check whether that is there in the output bucket which we have specified or not. If we have specified that the output bucket as innobus out, so let's go ahead and open that. All right, let's open innobus out bucket. We got word count as we specified, and we got output folder, inside which we got a date, inside which we got the processed output file, and it says success. And these are the 3 files processed with our input file which we gave to. Let's open it. Okay, that's the process file. So let's see in which file we got the output. It's not there, and now I have downloaded all these 3 files to which is the output file which is there in the S3 bucket. Now let's go ahead and open these 3 files and let's see what's the output which we have given through elastic MapReduce process. Alright, and we got the file over here. Let's open it. Open. I'm gonna open that with Notepad and open. Okay, A12, we have mentioned that in the source file, and that has been there in the file for one time. And let's see what's the other file, and it says B12 was there on file for one time. So that's about the output that we got from the elastic MapReduce. So now what we have checked is, like, we have given the input file and we have given a source file which says what is the file or what is the process, and we have got the output of what exactly the file count or the word count was there in the input file. If we look at the word splitter file which we have used to process the input request, which we have opened here, so it's a Python script what exactly it does is, like, it processes the input file and it works like splitting the words. We have given the input as A12 and B12, and it splits the word, the text in the Word doc, or otherwise the words in the text document starts with alphabets, and it prints how many number was there. That was the process file that we gave, and we gave the output of how many number of word files was there in the input file that we gave. This is a sample example that we have done with elastic MapReduce, and it can be used in an environment which runs Apache Hive, and for logging the Apache Hives we can use the same elastic MapReduce process for logging as well as for serving the content of to many number of resources simultaneously using the Hadoop network. That's all about the elastic MapReduce. Now let's go ahead and check what are the advantages of using the elastic MapReduce from AWS Management Console. The advantages of using elastic MapReduce is that it is elastic. As we know that elastic MapReduce enables us to use as many number of EC2 units for running the process. We have selected 2 core units to run the task. At the same time, if you want, we can go ahead and increase the number of cores into our elastic MapReduce job flow. We need to enable the debugging by which we can go ahead and add more number of core units for performing the operation, and it is reliable. The high availability and automatic replace of EC2 instances, as we discussed before. Hadoop itself detects for failure of instance, and it automatically replaces the failed instances with a new instance. So it is reliable, and it is secure. As we know, it works in coordination with firewall settings of EC2 or VPC. Whatever we mention on our firewall settings in the security group of our EC2 instance, the same reflects over there in the elastic MapReduce as well. So it is secure as well, and it is scalable. How can we scale the elastic MapReduce? Is how, based on the traffic or based on the simultaneous number of users that has access to our web or mobile application. Usually we can see that Adobe is being used by number of mobile applications where the end users are millions and millions of users. Hadoop is the best technology that can be used where the end user gets satisfied with using the application, and it is scalable in the number of cores that we use, or in the type of or the number of task cores that we use. We can scale it accordingly or as per the requirement, and it is inexpensive as well. Since EC2 compute units are shut down after the job, it is whenever it's completed, so we pay only for what we use. We don't need to manually go ahead and shut down the instances after the job flow of Elastic MapReduce. When the job flow is completed, it itself shut down the instance, so it is inexpensive, in other words, than any other Hadoop technology that we see in the cloud infrastructure today. Now let's check what is the other compute and networking component of AWS Web Services. Let's look at Route 53. Route 53 is a scalable domain name system available from AWS Web Services. Let's see what exactly Route 53 does. We know that we have a domain registrar from where we buy domains. For example, abc.com, we can buy from the domain registrar, and we point that domain to our server using the server's public static IP address. In that point of time, when an end user types abc.com in the browser, what happens in the background is that we all know the name is getting resolved by the DNS server, and the domain registrar then passes the IP address of that particular IP or server which we mentioned in the domain registrar domain management console, and it happens through the DNS servers which is available in the public internet. The DNS servers stores the information about the IP address of each domains. Here, in the case of AWS Route 53, same works. How it works in the sense, the Route 53 is an extremely reliable and cost-effective manner of translating DNS records. We can also call it as a DNS web services. And what is latency? Latency is nothing but when an end user types abc.com in the browser, and the time taken for the end user to get the page from the point he or she hits the enter button. That's what is latency. If it takes a long time to load the page, irrespective of the internet connection speed, we can call it as a latency issue. So the Route 53 is designed to work with low latency based routing. That's the way it is designed, and that's how it works. And it provides the LBR, latency based routing, and it also manages the mapping between the domain names and the IP address. We can compare it to a normal phone book. In a normal smartphone, we have a phone book in which we store the contact details, and when we call somebody, we go ahead and select the name, we click the call button, and we make the call, where in the background the number is getting dialed to the telecom provider, and when we receive the call, the number is getting dialed from the source and it comes to telephone provider, and the call lands on our phone. Meanwhile, the phone book translates that phone into the name on which we save that number, and that's one which is getting displayed in the mobile phone screen. Same as like that, DNS web service works. It translates the IP address to a domain name. At the same time, it translates the domain name to an IP address. And the advantage of using the AWS Route 53 is that it effectively connects the user request in the form of domain names to the AWS services like EC2, S3, Elastic Load Balancer, etc. And let's see what are the functions or what are the parts of Route 53. It has got two different functions. First one is DNS records, and another one is directory service assistance. The one which manages the IP address list of a domain name is called the DNS records. In a domain name, we can have A record, we can have SPF record, we can have MX records, we can have A records, and also we can have C names. All these are records associated with the domain name under the DNS management category, and all these records are stored by the DNS records part. And the directory service as a directory assistance service, what exactly it does is like it works as a directory assistance to translate these domain names into IP address as well as the IP address into the domain name. And this translation happens with the help of IP address or domain names. So these calls or these requests are called as queries. And also it has some other feature like hosted zones. What exactly the hosted zones? It is where the DNS records of our domain are stored. As we discussed before, the records like A record, MX record for mail, SPF record, all these records are stored under the hosted zones part. And it also provides no latency. It works fast with the help of using global DNS servers. How exactly the Route 53 handles the request? It communicates with the global DNS servers, which has the detail of DNS names as well as IP address, which has the indexing table. So the Route 53 communicates with these global DNS servers, and that's how it makes our server to work with low latency and otherwise no latency, which results in much improved end user experience. Now let's go ahead and check how can we launch and set up a Route 53 on AWS Management Console. We go to the AWS Management Console and we click on Route 53. Here we have to create a new hosted zone. So I'm going to create a new hosted zone where we have to enter the domain name. I'm going to mention it as inobus.com, and we can give a command to identify this. Okay, and we are going to click on create hosted zone. And now we can see that the domain name of inobus.com has been created as a hosted zone on our Route 53 management console. And on the right hand side, we can see that this is the delegation set. We can see 4 number of entries. All these are the DNS entries for our Route 53. We need to mention these DNS server names under the DNS server management in our domain registrar. Then only the domain traffic will be transferred to our Route 53 console in the AWS management. Now let's go ahead and create record set for our domain name. Click on go to record set. We can see inobus.com and we click on create record set. And let's go ahead and create an A record. Let's say cloud computing cloud.inobus.com, and we click on view. As of now, the Route 53 supports only IPv4, so we keep it as A record, and we're not going to add any aliases, and we're going to give a name for otherwise IP of our server or EC2 instance, which is running under Amazon Management Console. Here in the value, we can go ahead and give the IP address or the public DNS of our EC2 instance. So we can go ahead and type elastic IP if we have one, or else we can go ahead and type another IP address which is associated, or the public DNS name associated with our EC2 instance. And also we can mention other services like Elastic Load Balancer's public DNS name as well. So we give the IP and we click on create record set. And now on the right hand side we can see that cloud.innovest.com a record has been created. So same as like that, we can also go ahead and create an MX record, so like mail.innovest.com, and we select MX record here, and we give our mail server name, mail server exchange handler names like 10.mail.innovest.com, 20.mail.innovest.com, and 30.mail.innovest.com, and 40.mail.innovest.com. And we click on create record set. And there is a small difference in that, where we don't need to mention the dot. Since it's a priority value, we can make 10 space and our mail server name, and the values are 10, 20, 30, 40, followed by a space and our mail server name, and we click on save. And on the right hand side we can see that the mail entries or the MX record entries has been added to our Route 53 control panel. Same as like that, we can also have SPF record added to our domain names, and we can have NS name server names, and also we can have canonical names, C names to our domain server names. Same as we handle our domain registrar console, we can go ahead and add these names into our AWS Route 53 console. The important point under AWS Route 53 console is that when we are creating a new host, it's pretty easy. We can go ahead and create hosted zone, and we can enter the domain name and we create the hosted zone. In case if you are migrating our domain, which has a number of A records and a number of MX records and a number of C names, while we are migrating or moving those files, we need to enter the DNS name which we get from the AWS Route 53, as we have seen just before. These 4 entries, these must be given to our domain registrar. In case of, for example, GoDaddy or any other domain registrar, we need to enter it with the domain registrar for the communications to be transferred to AWS Route 53. And TTL may take up to 900 seconds minimum value, and within 2 days this propagation completes, and after that whole communication will be handled through AWS Route 53. So that's all about the AWS Route 53. It's another domain registrar for our domain. The advantages or the importance of using Route 53 in our infrastructure is that we are having our domain from a domain registrar, and we are having all our services running on AWS in case of our mail server, in case of web server, in case of application server, and database server. All these are running on AWS. In that case, to improve the performance or for much efficiency and with low latency for the end user experience, it's better to have Route 53 configured onto our AWS management console, so that it handles the communication with global DNS server, and the latency will be less, and the rendering will be much improved than keeping our DNS management settings in the domain registrar itself. Now let's go ahead and check what are the advantages of using Route 53. The advantages are they are highly available. The high availability, how we get is that the use of distributed DNS servers ensures the consistent ability. It communicates with global DNS servers which are distributed, and it communicates with these servers on a constant interval. So the updation will happen with a less latency of time, and therefore the latency for the end user will be much less. And also it is scalable. It is designed to be ready, automatically scaled to handle very large queries. As we know, the query, the each and every translation from IP address to domain name and domain name to IP address are considered to be queries, and the number of queries which AWS Route 53 can handle is scalable. It doesn't matter how many number of requests comes and what are the different requests comes simultaneously. The AWS Route 53 is designed to handle all these requests. And it is simple, as we have seen, it is simple and easy to manage, and also it is enabled with AWS API. So even the developer can access the API and can write code for any other activities. And it is fast as well. Since it communicates with the global DNS server, so it is based on a global anycast network of DNS servers around the world. It gives a low query latency for the end user and low update latency for the DNS records, which results in faster, improved performance of our website. Otherwise, in other words, domain name. And it is cost effective as well. There is since all the services are running under AWS Web Services, it's easy to manage and the communication can be pretty much hassle-free, and it's cost-effective as well from a business point of view as well. So that's all about the Route 53, and let's check what is the other product of AWS under compute and networking category. It is AWS VPC, in other words also known as Virtual Private Cloud. Virtual Private Cloud is a virtual network that you can design that resembles a network running out of your data center. As it says, they are isolated cloud resources. Using the VPC technology of AWS, you can run your cloud isolated from the public cloud, and you can use the resources available over the cloud. And that's why we call it as an isolated cloud. And it enables us to create an isolated web service cloud running on EC2 instance, which has private IP range that a user can define. The reason we call it a user-defined IP range, because we are creating a virtual private cloud that is isolated from the public cloud. Hence, the user gets the privilege to define the IP address range for the applications running under the VPC. And there are 4 different subnets available for the virtual private cloud. Let's see what are they. We can have a VPC with single public subnet. We can have with public and private subnet. We can have public and private subnet with VPN access, and we can have a private only VPN and hardware based virtual private cloud from AWS. Since we are isolating it from the public cloud, we get another features like ACL and NAT, which is an access control list and network address translation for the resources that are running under our virtual private cloud. We can have our own rules to write an ACL, and the communication between the resources inside the virtual private cloud as well as from the public internet would be monitored by the ACL, the access control list, and the NAT. And also the security groups will be used for monitoring the inbound and outbound traffic. Monitoring in the sense, if it is said to be transferring the content to the public internet over a particular port, that needs to be mentioned on ACL or security groups. Otherwise, the traffic or the communication will be limited to the resources available as per the ACL or the resources available under our own VPC. And another important point about virtual private cloud is that it supports IP security. we can go ahead and set our own IP security parameters and settings to prevent our server from attacks or hacking kind of actions. Now let's check what are the components of virtual private cloud. And as the name indicates, it's isolated from the public cloud, and our resources are allocated only to the users who have access to the VPC, our own virtual private cloud. And the component is subnet. Let's see what are subnets. Subnet is a resource group to be placed in an isolated VPC address range. So what it does, the subnet is the one which is being assigned to each and every resources available over the cloud. Using the subnets, we differentiate the resources. The resources can be any AWS resources available in the AWS management console. We can have RDS, we can run EC2, we can run S3, we can run Elastic MapReduce. All these services can be launched and configured under the VPC. So the subnets are used to limit these resource groups for the IP address communication. And we have Internet Gateway. This is the one which handles the public internet traffic, or the public internet gateway. That is the first firewall or the first gateway to which the communication from the public internet lands before it reaches any of the resources inside our virtual private cloud. And it also has NAT, which is network address translation, and the port address translation happens at the NAT component. It also supports, or it also gives, hardware VPN for connection between users, AWS and VPC and data centers, or its own home networks. All these are communicated through the component of hardware VPN. And we also have VPN gateways. It is that which connects to Amazon VPC slide. The VPN gateway is used for the communication from the public as well as private. The private IP range communication as well as public IP address communication, all these are being transferred through the VPN gateways. And also it has got another component which is called gateway customers. The VPN gateway that connects to the user side is called gateway customer. And router, which is nothing but the internet gateway plus VPN gateway plus the NAT instance and the direct traffic. Everything comes under the router component of virtual private cloud. Now let's take a look at this figure and let's see how exactly the virtual private cloud works. Alright, in the figure we can see that the internet and the communication to the cloud, and we can see the VPC inside the Amazon Web Services, which is a cloud, and the VPC is a cloud which is inside the Amazon Web Services. So first the communication comes to internet gateway, and the internet gateway then listens to the communication port, and based on the ACL and NAT rules, it transfers the communication to the resources available in the private cloud. And it gives subnet, which is user defined, and also it has got EC2 instances that are running inside the virtual private cloud, and the security group of that EC2 instances are also be connected. So based on the NAT, ACL and the security group, so the rules that we write on these three components decide whether to transfer the communication from the public internet to our virtual private cloud. And the IP subnet which we get or which we define while creating the virtual private cloud, those range of IPs will be assigned to each and every resources that we allocate in our virtual private cloud, and 4 virtual IPs in that category will be reserved. The first 3 and the last one will be reserved by AWS, and The rest will be used for each and every resources that we use. And the important point is that we won't be able to change a private IP which is assigned to a resources. Even if you restart or even if you stop the instance, the IP is allocated to that resource. We won't be able to change that IP address. And we can see the communication which depicts in the yellow line from the subnet and from the resources. That communication goes to the public internet as well as to the other Amazon resources running in the Amazon public cloud, EC2 and S3. All these resources can be communicated to our resources in the VPC. Now let's take another figure which depicts the communication to the virtual private cloud from different parts of or from different data centers. Imagine the ABC company. ABC is running their virtual private cloud in Amazon, and they have their own data centers in 3 different or 4 different places. We have got Los Angeles, Chicago, New York and Miami. All these data centers are communicating with the resources available under AWS cloud as well as the resources available under AWS virtual private cloud. So the communication comes through the as a VPN connection. It reaches our virtual private gateway, which is a VPN gateway, and the VPN gateway then decides the communication based on the port and the NAT rules, and then transfers that request to the resources that are available under the virtual private cloud. It could be a database server, or it could be a EC2 instance, or it could be an RDS server. The communication through the VPN is only through the VPN, which is another way of securing the communication, and based on the rules the permission is being given to the request. Now let's go ahead and check how can we configure a virtual private cloud in the AWS management console. We log into our AWS management console and we go to virtual private cloud, and in the virtual private cloud we can see that in the dashboard it shows in which region we want to launch the virtual private cloud. We can see we have got different regions in which we can create the virtual private cloud. In US we have got nearly 4 regions, and 2 in Asia Pacific, 1 in Europe and 1 in South America. So let's go ahead and create a virtual PC, a virtual private cloud. So let's click on the virtual private cloud, and here we can see, as we discussed in the beginning of virtual private cloud, there are 4 different subnets or 4 different types of VPC that we can configure. So the first one is a VPC with single public subnet only. That means our instance run in a public and isolated section of AWS with direct access to the internet. The network access control and the security groups can be used to provide strict control over the inbound and outbound network traffic. We can see the inbound traffic from the public cloud to our resources in the virtual private cloud. The resources can be S3, EC2, Simple DB, RDS, or any other resources which we run and allocate to our VPC. And if we select the single public subnet only, the traffic from the public internet will be open, and also it will also listen to the security group as well as access control list before transferring the communication. And another mode is that VPC with public and private subnet. And let's see how exactly it works. So in addition to the public subnet which we have seen just before, this configuration adds private subnet whose instances are not only addressable from the internet. The instances is a private subnet can be attached to the instance, and the outbound connection to the internet via the public subnet and network address translation. We have a public subnet under our VPC, and we got a network address translation system and our resources. So all this has come to picture before the traffic or the incoming requests are transferred to our resources in the virtual private cloud from the public internet. Let's see what other method of creating the virtual private cloud and configuring the virtual private cloud. In this configuration, what happens is like it adds an IP security virtual private network connection between your Amazon VPC and your data center. We got a VPC which has our own resources, and we got a data center. So the communication between our VPC and the data center effectively happens through a VPN connection. What's the advantage of using this is that the communication from the data center to the VPC is made easy and secured through the VPN connection. At the same time, our virtual private cloud has access from the public cloud as public internet. And let's check the final configuration type of creating a virtual private cloud. This one, as the figure indicates, it doesn't have access to a private it doesn't have access to the public internet. The communication to the resources available under the VPC subnets will be accessible only through the VPN tunnel using the IP security as well. So let's go ahead and create a VPC with the single public subnet only. Click on continue. And here, as we discussed before, the user has a privilege to go ahead and mention or to define the subnet. So we can define any range as it shows the class A IP address. I'm going to keep it as class A IP address, and we click on create virtual private cloud. Okay, the virtual private cloud has been created. We click on close, and we can see that we have a virtual private cloud running under our the Amazon management console. So how exactly this works? The virtual private cloud, as the name indicates, it's nothing but an isolated cloud from the public cloud. You can run all the resources which are available in Amazon management console, or in other words, which are available in Amazon web services under VPC. As it indicates, we can go ahead and create and launch EC2 instance as we discussed before in the virtual private cloud, and we can launch our own RDS systems. We can create access to S3 buckets. We can create elastic MapReduce. All these instances can be created in virtual private cloud. When we click on that create an EC2 inside a VPC, it gets back to the EC2 instance, from where we need to launch an EC2 instance again. And the difference is that we attach the EC2 instance to the virtual private cloud, and the IP address given to that EC2 instance will be associated from the CIDR associated with that virtual private cloud that we have just created. We can allocate our own IP address, we can create subnets, and we can create network address translation. Everything can be created using this. Since we have selected a public internet only, the current virtual private cloud has access to the public cloud. The request from the direct internet or the public internet will be handled by this VPC. So that's how we create the virtual private cloud. So any resources like elastic MapReduce, CloudWatch, EC2, RDS, all these services can be created even under our virtual private cloud. Now let's go ahead and check what are the advantages of using virtual private cloud. Also, we can check what is the routing and the topology used under virtual private cloud. AWS VPC router enables EC2 instance within a subnet to communicate with EC2 instance in other subnets within the same VPC. So the public IPs are not assigned here. It's all about the communication between private IP address, since it allows the communication between the resources inside the same virtual private cloud. As we discussed before, the private IP address cannot be changed, and the subnets are created when we create that virtual private cloud, and it's user defined. And the private IP addresses are static. We may not be able to change the private IP address associated or attached to a resources in our virtual private cloud. The virtual private cloud, it has a router, as we discussed before. It enables the communication between the subnets and internet gateways and the VPN gateways to each other. We have seen that router which has NAT, ACL and gateways and VPN gateways. The communication with these three components as well as different resources in the VPC is based on the routing table of the virtual private cloud. And it uses the routing table. It is a table where the user can create routing rules to specify which subnets are routed and how the communication is being transferred from one subnet to another. And the advantages of virtual private cloud is that it allows multiple connectivity options where the end user can communicate with the resources available under or inside the virtual private cloud based on the type of VPC that we create and the communication or the connectivity between the resources available in the virtual private cloud. And the multiple connections of connectivity is possible while using the virtual private cloud, and it is secured since it uses NAT, ACL and security groups. The inbound and outbound traffics are being filtered based on the rules that we write. So we can certainly say that the VPC is secured and it is simple. We have seen that it won't take more than 5 minutes to create a virtual private cloud and creating other resources inside the virtual private cloud and attaching into the private IP of that or the private subnet of that virtual private cloud. And it's scalable and reliable. As we know, in AWS cloud, most of all the services offered under AWS services are scalable and reliable. Scalable in the sense since it provides a feature of elasticity. All these resources are scalable based on the user requirement. We can increase or decrease the resources allocated to our services. It can be virtual private cloud or it can be private cloud. It is possible to scale the resources for each individual service. In case of EC2, let it be on the private cloud or a virtual private cloud, we can scale its performance in terms of resources of memory, resources of CPU, resources of cores. The elastic compute units which we have on that instance are scalable. Since it provides the multi-zone availability on VPC as well, the reliability is also being given to the end user while creating the resources under the VPC. So that's all about the compute and networking components of Amazon Web Services. It has got different use for each and every services available under this category. The EC2 units are used as compute units or processing units, and the Route 53 is used for DNS management, and the virtual private cloud is used when we have to isolate our resources from the public, and the Elastic MapReduce is used when we have to process millions of requests simultaneously, in other words parallelly, from millions of users. So these resources are the processing or computing resources available from the AWS in this category.